Hey guys, how you doing? This is Renan with Piece of Pie Learning, and today we're going to learn a little bit about exponential functions. So before we get into that, I will remind you what a linear function looks like. So y is equal to mx plus b. The reason I'm doing this is because on the SAT, they tend to compare the two. And also just for memory purposes, it's always nice to have two things to compare. So the main difference between them is, well, at least in terms of the equation, is that in an exponential, the variable is an exponent, right? Exponential. And in linear, it's not. The other thing you want to notice between them is that in exponential, you're multiplying, right? It's a times b to the x. Whereas in linear, the main operation is addition, mx plus b. The final thing you want to know about these two, the difference between these two, would be, where am I going to write this? Write it right here. That a linear tends to look like a straight line, hence the word linear, right? Line linear. Whereas an exponential is a curved function. So both of these graphs, right? The one on the right curves as a growth. It increases quickly, whereas the other one decreases quickly, right? So that's the main difference between these two. Now on to exponential specifically. So the equation you have to know for this test is y is equal to a times b to the x. In your Algebra 2 class, you may have learned that there is a plus d involved as well, right? Which will generally shift it up or down. For the SAT, you generally don't need to know that. For like 99% of the problems, this will suffice. All right, the first thing you have to know about this equation is what a represents. The coefficient a represents on a graph the y-intercept, right? And in a word problem, it's the initial amount, the starting amount of y. So over here, for example, a is 3. You may not be able to tell that based on the graph because of the scaling, but in the videos that come after this, I do go over this and this example in detail. Here a is 128. Awesome. That's the y-intercept. Now, what's b? So the reason we call b a factor will make sense right now. Let's make a little table, x and y. X is 0, 1, and 2. So at 0, y is 3 because that's your y-intercept. Remember, when x is 0, the y value is your y-intercept. Just a quick recap of what I've explained in other videos. So when x is 1, right here, that's 6. And when x is 2, that's 12. Now, if you notice, every time that x increases by 1, y gets multiplied by 2 times 2 times 2. So this repeated multiplication is b. And that's why it's called a factor, because factors multiply. And because it's greater than 1, it's a growth, right? That's why it's growing quickly. So the full equation for this, hold on, so b is 2. And the full equation for this will right here is y is equal to 3 times 2 to the x. Now in this example, we already saw that a was 128. Now let's make a table as well. So that's real crooked, nice. 0, 1, and 2. So at 0, it's 128. At 1, you can't really tell, but that's just below 65, so that's 64. And at 2, that is 32, right there, boom. So as you can see right here, this function is decaying, right? As x increases by 1, right? Plus 1 plus 1, the function actually gets cut in half. You can see that as either dividing by 2, or like the SAT wants you to see it, it's getting multiplied by a half, right? So times a half times a half. That makes our b 1/2. And that points to this here, where you can tell that it's a decay if b is a positive number, so greater than 0, less than 1, right? And this is a half is less than 1. You can quickly tell that it's less than 1 if you have a fraction in which the denominator is larger. So for example, this 4/3, that's greater than 1. That's a growth. But if you had 3/4, that is less than 1. That's a decay. So our final equation here would be y is equal to 128, nice, times 1/2 raised to the x.